Okay, so this video is just going to go through how I did the different problems that we talked about in notes. So it's a good review, how we did the energy and work problems. So in this video here, this was just an example of how you calculate potential energy. And it stated that a cat climbed to the top of a tree. The tree is 20 meters high and the cat weighs 6 kilograms. We want to know how much potential energy we have. So of course we have to start with our equation. The potential energy is equal to the mass times the height times the acceleration due to gravity. And here they use g as gravity. So what we have here is we have the mass, which was 6 kilograms, times the height, which was 20 meters, times the gravity on Earth, which is 9.8 meters per second squared. When we run all that through the calculator, we get 1,176. But the unit, because we have a kilogram, a meter, and a meter per second squared, is referred to as a joule. Energy is measured in joules. So the potential energy, that's the energy of position, would be 1,176 joules. So in this example, we're going to look at kinetic energy. And kinetic energy, again, has the equation that kinetic energy is equal to 1/2 the mass times the velocity squared, because kinetic energy is the energy of motion. So the units, again, mass has to be in kilograms, velocity in meters per second squared. And here's our example problem. What is the kinetic energy of a 45 kilogram object moving at 13 meters per second? So again, we would have the equation. Kinetic energy is equal to 1/2 the mass times the velocity squared. So we would have 1/2 the mass here of 45 kilograms times the velocity squared, which would be 13 meters per second squared, and the whole thing is going to be squared. So when we run things through the calculator, we have 45 divided by 2 times 13 squared, which happens to be 169. When we run all that through the calculator, I get 3,802.5, and again our unit is going to be joules. 3,002.5. Forgot a 2 there, sorry. So on this practice problem, we're going to look at work. It says that a person lifts a bag of groceries that weigh 175 newtons. The bag is lifted 1.2 meters. How much work would be done? So again, from our equations, we know that work is equal to the amount of force times the distance you have to carry it through. So force would be 175 newtons times the distance of 1.2 meters. Run that through our calculation, and we get 210, and the unit is a joule. In this problem, it says you have 28,561 joules of work is done to move a car 26 meters. What is the force applied? So in this one, we need our equation first. So this force equation is going to be equal to the work divided by the distance, which would be equal to 28,561 joules of work divided by 26 meters. Numerically, when I divide that out, I get 10,098.5. that should probably be 1,098.5. And since force is measured in newton, we could break these units down, but we're just going to assume that force is going to come out as a newton. So it would be 1,098.5 newtons. So in this practice problem number 3, it says we have 540 joules of work is done moving a rock off a road. The person moving the rock applies a force of 185 newtons. What distance was the rock moved? So here our equation would be equal to distance is equal to the work divided by force. So the amount of work was 540 joules divided by the force of 185 newtons. So when I run that through my calculator, I get 2.92. My units, since we're looking at distance, is going to be meters. So now we're looking at the power practice problems from our notes. Number 1 says that a person applies 53 joules of work to move a chair across the room. It takes 5.2 seconds. How much power was used? So power is equal to work divided by time. So that would be 53 joules of work divided by the time of 5.2 seconds. And when I divide that out, I get 10.19, and the unit is going to be joules per second of power. Number 2, it says 854 joules per second of power are used to drive a car 65 seconds. How much work is done? So on this one, now you got to watch, because you have to watch the type of work equation you're going to use. Since you have power and time, you're going to use the equation that work is equal to power times time, okay, which would be the power would be 854 joules per second times the time of 65 seconds. You'll notice that the units of seconds divide away. That's going to give me an answer in joules, which is what work is going to be reported in here. And when I run it through my calculator, I get 55,510 joules of work. So you got to watch work. You got to watch which equation you're going to use for work. You always have to look back. Oh, I got seconds, I got power. So I'll use this equation here. And my last practice problem, it says here if you have 562.14 joules per second of power, and they're used to lift a steel beam by a forklift, 542.13 joules of work is applied. How long does it take to lift the steel beam? So what we're looking at here is time. So that would be equal to work divided by power. And my work, okay, since I'm lifting, is going to be 542.13 joules. The power is 562.14 joules per second. So units, joules divide away. Second is going to come up into my final answer. So my final answer is going to be in seconds. And when I mathematically calculate it, run it through the calculator, I get 0.96.